Welcome to Homework Lib.
Hi, so for this problem, essentially what you need to remember is, first of all, only the definition for pH, that is minus the logarithm of the concentration of H plus ions or hydronium ions, whichever you want to get. And from here, we can solve for the concentration of H plus, that is going to be 10 to the minus pH. Okay, so for the first one, since beer has a pH equal to 4.3, this implies that the concentration of H plus is going to be equal to 10 to the minus 4.3 molar. And 4.3 molar, that corresponds to 5.012 times 10 to the minus 5. Here, of course, depends on what is being asked of you on terms of significant years. If they ask you for 2, stick with 2. If they ask for 3, you can set up the result tests. So next up is, for the second question, which single component buffer would be the best for making a pH set equals 75? For a pH equal 7.5. And the way to know this is taking into account the Henderson-Hasselbalch equation, which tells us that the buffer, it is going to depend essentially on the pKa of the compound that we have. So if we want a pH of 7.5, we want a compound with a pKa close to 7.5 or as close as possible. So for the different options that we have, for A, you have MES, that tells you that it has a Ka of 8.13 times 10 to the minus 7. This implies that pKa, remember this is minus logarithm of Ka, pKa, it is going to be 6.09. Now we need to do the calculation for all of the possible options that we have. The second one is pipes with Ka of 1.74 times 10 to the minus 7, 1.74, sorry, which gives us a pKa of 6.76. We start to getting closer. For C, they call it MOPS. The Ka is equal to 7.08 times 10 to the minus 8. This implies a pKa of 7.15. For D, the Ka is 3.39 times 10 to the minus 8, which corresponds to pKa of 7.47. So we're starting to get close to our ideal pKa. And finally for E, that is trees, the Ka is 8.32 times 10 to the minus 9, which corresponds to pKa of 8.08. So the one that is going to be ideal for creating a buffer at 7.5, it is going to be D, because we have the closer pKa to the pH that we require for our solution. And that will be all.